In this video, I'm going to show you how to get started using the Docker CLI, the command line interface, to talk to Docker on Windows. So I'm going to open a terminal with git bash, and I'm going to try to docker ps, the most basic command to see the Docker processes that are currently running. And there's an error because the Docker desktop is not running. So I will open Docker desktop, and then that will start up, and I'll be able to see a taskbar widget right here, or that will show you the Docker desktop is now running. And even if I close this window, Docker desktop is still running, and I can click on this to reopen that window. So to run some sort of command with Docker, we just say Docker and then some subcommand. So ps will show us the empty table name of the containers currently running on our system. We can do ps-a to get containers which are exited, of which I currently have none. You can also do Docker images to show the images that I have downloaded on my computer right now, or the ones that I have built myself. So let's see about using a familiar image, the Nginx image from Docker Hub. So we'll go to Docker Hub and look at the Nginx image, which is a common image containing a base operating system and then the Nginx web server. So we can look at tags and see different versions of this. And I know that I want an Alpine based tag, so I'm going to look for Alpine, and I see this 320 version, so I'll look for 320. And then I don't want Perl. I don't know what Perl refers to in this context, so I'll take this one. So I could pull this image with Docker pull, but it'll also automatically get pulled when I try to run it. So I'll go and try to run this image, and it's going to download and then attach me, and I'm seeing the standard output from Nginx. And Nginx is the command that the container is supposed to run. So it's its whole job to run Nginx. And if I open another terminal and do a docker ps, you'll see that that is running. But when I control C to stop this process, it will exit the process and it will exit the container, because that was the container's whole job. So docker ps now shows nothing is running. However, the container is not completely gone. It just stopped running. So we can see that here in Docker Desktop, that the container is no longer running. We could start it, and we could stop it, but it's still there. So in order to see that in the command line, we would do a docker ps-a, and you could see even exited containers. So note that this has been given a container ID and a container name, and that's because we didn't specify a name. It was given this random name. So if I do, if I want to get rid of this, I have to either reference it by its ID or its name. So I could say docker rm and then the name of the container. And then docker ps-a will return nothing because this has been deleted. So if you don't have your containers delete themselves when they stop, they will stick around. So how do you make them delete themselves? With --rm. And notice that this flag --rm is going after run, but before the name of the image we want to run. So now when this exits, when it's running, you'll see docker ps is going to return that something is running. But when I control C to stop and I do docker ps, even docker ps is going to be nothing because it's not running, and docker ps-a is going to be nothing because it has deleted itself when it exited, because we passed that rm. Now, we are automatically attaching to Nginx, the Nginx output, so it's kind of trapping our terminal. So if we want to just run that in the background, we can do -d, and that's going to run it in the background like we had if we had started it from the Docker with the run button. So now docker ps is going to show us that the container is running, and it's been up for 8 seconds, and now it's been up for 14 seconds. We can docker stop it by name or ID, but ps-a, it's gone because we had that rm flag. So if you wanted to stick around, just make sure you don't pass rm, and if you wanted to delete, do pass rm. So let's say we run in the background, and we do this 3 times. So now if we do ps, we should see those 3 running containers, and in fact we do. And we should see ps-a shows those same containers because it's including both running and exited, but we only have running here. So let's say we docker stop one of them by ID and do docker ps-a. We see that the containers are still sticking around because they were run without the RM flag. Now if we want to docker start them, we can docker start and then the name of the container or the ID, and ps should show us now that they are all in fact running. So if we go to the port that the Nginx web server is using, which I happen to know is port 80, we should see this, right? Well, it's hanging up. So that's because the TCP port that this is using it's being used inside of the container, but it's not actually being mapped to a port on our host machine. So the Docker containers actually by default can talk to each other. So this container here could actually talk to port 80 in this container and this container, the way the default running networks work. Docker creates like a little Wi-Fi network. You can think about it like for the containers that you've run from the command line, and unless you specify otherwise, they join this Wi-Fi network, and so they can all kind of talk to each other. But they can't actually talk to the host system, and that would be a problem anyway if you think about it, because look, they all use TCP port 80, and port 80, there's only one of those on my host system. So multiple Nginx servers cannot bind to port 80 and listen for connections. Only one server can do that. And so as a result, I would have to pick which container I want to actually have port 80. So I'll go ahead and start another container. And this one, I'm instead going to give its custom name. I'm going to say -- name my Nginx C. And now, yes, we see I get that custom name I set. But actually, I want to stop it and remove it. So I'm going to docker stop my Nginx C. And docker ps, it's gone, but docker ps-a, it's still around. So I have to actually remove it. So I can do docker rm and then the name of the container, and it's gone. So what if I stop the other ones? Nothing's now running, but all these containers have stuck around because they were not set to remove on exit. So I could delete these one by one with docker rm, or an easier way is to do docker container prune -f for force. So this is an interactive question, and it just says yes to that question when you do -f. So now PSA is going to return nothing. Those have all been cleaned up for us. Now let's go back and run our container by name, my Nginx C, except I'll call it Nginx C since we just have one now. Or I'll call it NXC for short. Now, if I want to connect this to the host system, I actually need to pass a port. So you may have seen this before, but the way you'll do that is with -p for publish, and then the port you want on the local system, so 80, say 83, and then to the 80 port that the Nginx is going to be using inside of the container in this case. So now that's running in the background, and I'll see in Docker Desktop that we're mapped to 8083, and I can click that link and see the Nginx server is working fine. Notice it's not port 80 like it is in the container, it's the port we've mapped 80 to, which is 8083 in this case. So if I do a docker ps, I see that that's still running, and I can do things like attach to that container or execute commands in that container. Let's see what that looks like. We know its name is NXC, so we can do docker exec NXC, and we can then execute a command inside of that container that container has inside of it. So for example, maybe it has a bash shell. No, it doesn't have a bash shell. Maybe it has an sh shell. It does seem to have an sh shell, but sh shells or bash shells are interactive. So we actually need to pass an interactive -I for keep standard input open, and T for create a pseudo terminal that we can use. Or you can also separate these like this, either IT, TI, -I-T, or -T-I, -T-I. And then we can do an ls, we can say which nginx, etc. And we're running this inside of the container. So if we do ps, we should see that nginx processes are running as well, because elsewhere that web server is running as the main process for our container. But we just have this shell process that we can exit, and now that nginx process is still running. So it just allows us to execute a command inside of that container. We can also do that with our docker run command. So say we have nxc2, and we're not going to map 8083 to port 80 because we would run out of port 83s. We only have one of those, so we'll make it 8084 to 80. And then we can run this container, and we can, instead of running, well, the ports don't really matter if we're not using nginx. So let's delete that and say -IT for keep standard input open and give us a nice terminal interface, and then we'll have to actually run a terminal application like sh. So we'll docker run, but instead of running nginx, we're going to override nginx as the main thing to run and run sh instead. So what happened? Well, we actually ran it in detached mode because we had -D right here. So it did what we told it to. It kept standard input open, and it opened the sh program. It did not open nginx, but it ran it in the background. So to attach to that, we actually have to do docker attach nxc2, and then we get that shell. And when we control D to exit that, now it's exited. But it's still stuck around because we didn't have it remove itself. So I'm going to docker rm that, and then I will rerun, except I'm going to remove -D, and I'm going to have it --rm remove itself when it exits. So now we're running here, and if we do from another terminal, docker ps, we see that both those containers are running, nxc2 and nxc, the one with the web server. And we'll see docker ps, well, ps. So there's no docker inside here because we're in the container. If we do ps, we see that the shell script is running, and we just ran the ps command, and nothing else is running. So you see that nginx did not actually run here, whereas in the other container, nginx is running. If we control D, now docker ps, we're not running, and docker ps-a, we also are deleted because we set to rm on exit, and the main program we were running was not nginx, it was sh, and we ran it interactively. So when we ended that shell session, it exited the shell, and then it exited the entire container. So that's important. Containers essentially have one job to do, whether it's in this case the web server, or in this case an interactive shell, and we can attach to them or we can not attach to them, but whenever we have exited that program, the container itself is going to shut down. A solution to that is if you wanted to, say, keep the container open with a terminal ready to go, you could do something like shitd, and then docker ps, it's going to be open, but rather than actually docker attach to that nxc2, you could just docker exec another shell, docker exec -it, and then run the shell from another process. And then if you did a ps inside of there, you would see there are two shells running. There's the shell that's keeping the container open, and then there's the shell we're running and the ps command that we just ran. So when we exit this with control D and we do docker ps, we'll see that that container is still open because we never docker attached to that container. The other thing that we can do is, we can docker logs, and then nxc, which is the web server one, and we can see what the web server was doing. We can notice that this just exits after, so it just shows us all the logs that the main process that the container is doing has spit out so far. But if we want to follow those, we need to actually do logs-f for follow, and then we can follow them as they happen. And so since we've mapped this to port 8083, if we go visit that web server and we reload, we should see some logs related to connecting to that web server. And you see every time I refresh the page, we get a new request coming out in the logs. But the nice thing about this is, whereas when we attached to the Docker process and saw these logs through attaching or through running the container without -d, then when we hit Control-C, we actually exited the Nginx process, and so we exited the entire container and it stopped running. But if I do a Docker PS, the container is still running, and the reason is because we were watching the logs, and so Control-C was ending the log context. It was not ending the actual container process. So there's kind of two different pieces there, whether you're Docker attaching to what's going on or whether you're simply looking at the logs to get some visibility. So that is a pretty good intro to running both interactive shell sessions inside of containers and running web-based services. You'll notice that there's not a lot of graphical user interface that we have with Docker. We can obviously use Docker Desktop, and then we can create web services that can give us graphical interfaces in the web. And there are other ways to have graphical interfaces inside of Docker containers, but keep in mind that the biggest way that you're going to be able to interact with containers is through this shell interface. And so it's very common for containers to have a shell installed so that they can give you some interactivity in some way. It's not a requirement, but it is very common because Linux distributions often come with a shell. So that'll wrap it up for this one, giving you kind of an overview of the basic Docker CLI commands. There are many more, and if you want to check them out, you can go to Docker CLI reference and just look at the Docker docs, and you can see all the different commands like Docker containers, Docker container exec, which is an alias for Docker exec, for example. And you can see all the arguments that these take, like click on them and see more about that flag or whatever it may be. Thank you for watching, and I'll see you in the next one.